Hello everyone, myself Prasad. Today here on the topic flexural failures of PSCB. Let us look towards the content, introduction, types of flexural failure, prevention, and construction practice. Let's look towards the introduction. In the pre-stressed concrete, PSC beams are commonly used in the bridge and building construction. Flexural failure in PSC beam can occur due to various reasons. Understanding the types of flexural failure is crucial for designing and maintaining safe structure. So this is the picture of a PSC beam. Now let's look at the types of flexural failure. There are actually three main types of flexural failure in the PSC beams. They are brittle failure, ductile failure, and shear failure. Each type of failure has distinct characteristics and implications for the structural integrity of the beam. Now let's observe each type of flexural failure in detail. So in this figure, you can see how the flexural failure occurs. The first one is brittle failure. The brittle failure in PSC beams is characterized by sudden and catastrophic cracking. It often occurs when the concrete reaches its ultimate compressive strength before the steel yields. Brittle failures can lead to a rapid collapse of the beam without warning, posing a significant safety hazard. The next is ductile failure. Ductile failure in PSC beams involves gradual deformation and cracking, providing warning signs before ultimate failure. It occurs when the steel reinforcement yields before the concrete crashes. Ductile failure allows for some degree of deformation and energy dissipation, making it a more desirable failure mode compared to brittleness. Now let's towards the shear failure. Shear failure in PSC beams happens when the beam fails due to diagonal tension exceeding the shear capacity of the concrete. It is more common in shorter span and heavily loaded beams. Shear failure can lead to sudden and unexpected structural collapse if not properly accounted for in design. So the diagonal tension failure occurs near the support. The shear force is large as compared to the bending moment. The crack forms makes perfectly with the horizontal. Now let's see the causes of flexural failure. Flexural failure in PSC beams can be caused by overloading, poor construction practices, inadequate design, or material defects. Inadequate pre-stressing force or improper detailing of the reinforcement can also contribute to flexural failure. Understanding the root cause of failure is essential for the implementing preventive measures and ensuring structural safety. Let's see towards the prevention of flexural failure. To prevent flexural failure in PSC beams, poor design consideration, material selection, and construction practices are crucial. Adequate pre-stressing force, appropriate reinforcement detailing, and regular maintenance can help mitigate the risk of failure. Structural monitoring and timely repairs can also prevent catastrophic failure in the PSC beam. Now looking towards the design considerations, during the design phase, engineers must consider factors such as span length, loading conditions, and material properties to prevent the flexural failure. A proper distribution of pre-stressing force and reinforcement along the beam length is essential for ensuring structural stability. Next is advanced analysis techniques and computer simulation can aid in predicting and preventing flexural failure in the PSC beams. Now the material selection. Selecting high quality concrete with adequate compressive strength and durability properties is essential for preventing flexural failure. The quality and properties of pre-stressing steel also plays a significant role in structural performance of PSC beams. Using corrosion resistant materials can increase the longevity of PSC beam and reduce the risk of failure due to material degradation. Now the construction practices. Proper construction techniques including accurate placement of reinforcement, careful handling of precast elements, and effective pre-stressing procedures are critical for preventing flexural failure. The monitoring and quality control during construction can help identify potential issues early on and prevent structural deficiencies. Now, training and supervision of construction personnel are essential to ensure that best practices are followed during construction of PSC beams. Now, looking towards the maintenance and inspection, regular inspection and maintenance of PSC beams are necessary to detect signs of distress or deterioration that could lead to fractural failure. Non-destructive testing methods such as ultrasonic testing and visual inspections can help assess the condition of PSC beams without causing damage. Prompt repair of cracks, spalling, or other defects can prevent further deterioration and extend service life of PSC beam. Now looking towards the case studies. Examining real-world case studies of flexural failure in PSC beam can provide valuable insights into the cause and consequences of such failure. Lessons learned from the past failure can inform future design, construction, and maintenance practices to prevent similar incidents. Case studies highlight the importance of thorough analysis, quality control, and proactive measures to ensure the safety and integrity of PSC beams. Now concluding, flexural failure in PSC beams possesses a significant risk to the structural integrity and safety of bridges, buildings, and other infrastructure. Understanding the types of flexural failure, their causes, and preventive measures in, is essential for designing and maintaining resilient PSC beam. By implementing proper design, material selection, construction practices, and maintenance protocols, engineers can mitigate the risk of flexural failure and ensure the long-term performance of PSC beams. Thank you.